Today we are going to solve some questions which will help you to solve in graded assignment. Okay, so here we have with our first question. Tom has 6 different cars. He planned to go on a ride for the next 4 days. In how many ways can he select the cars if he decides not to use the same car twice? So how many cars are there? There are 6 cars. And for how many days he is going? 4 days, correct? So the question is, how many ways can he select the cars if he decides not to use the same car twice? That means that for the 4 days he is going to select different cars for each of the day, correct? He is not going to repeat it. So the solution is, Tom has to choose one car for each day. The number of ways he can select a car for the first day is 6. Out of the 6 cars, like there were total 6 cars, right? From these 6 cars, he has to choose one car. So there are how many ways? 6 ways. Then the number of ways he can select a car for the second day will be 5. Why? As one of the car is selected for the first day and he cannot repeat it again, right? So there is no repetition here. So one car is already selected on the first day. So how many remaining? 5. So there are 5 ways. The number of ways he can select the car on the third day will be 4 because 2 cars are already chosen. Only 4 are remaining. So there are 4 ways. Then the number of ways he can select a car for the fourth day will be 3 because 3 cars are already selected. So 3 are remaining. So there are 3 ways to select a car for the fourth day. So the events are occurring simultaneously. Therefore, the total number of ways of selecting an item will be 6 into 5 into 4 into 3, which is 360. Okay. Now, the second part of the first question is, in how many ways can he select the car if he can select the same car on different days? Okay. Now here we have repetition. Correct? That means like if I select a car on the first day, I can use that same car on the second day as well. Okay. So there is repetition. Okay. So the solution is, Tom has to choose one car for each day. The number of ways he can select a car for the first day will be 6. For the second day will also be 6 because there is repetition. He can repeat the cars, right? So if one car is here, he can, for the next day also he can choose from the 6 cars, right? Now the number of ways he can select the car for the third day will be 6. For the fourth day will be 6. So by multiplication rule it will be 6 into 6 into 6, which is 1296. So this is our answer. See that these are the number of ways of selecting an item or selecting a car for the 4 days. Okay. Now, second question. A group of five people decides to join either the sports or heritage team in the college. One can be a member of one and only one team. Okay, just remember this statement. In how many ways can they join the team if not necessarily each member of the group joins the team? Okay, so here we have been given that there are a group of 5 people and they decide to join either the sports or the heritage. Okay, and the condition is only one can be the one can be the member of only one team. Okay, the question is, how many ways can they join the team if each member of the group joins the team? If it is not necessary that he has to join the team or not. Okay, so the solution is, either a person can be in the sports team or the heritage team, or he cannot be in any team. Okay, so there are 3 conditions, there are 3 choices for the student. So each person has 3 possibilities, right? So the number of possible ways in which they can join the team is 3 raised to the power 5, right? How? Like there are 5 students, right? 5 people in a group. So for the first person, there are 3 choices. He can be in the sports team, right? ST for the sports team, heritage team, ST for the heritage team, or he is not in the team. He is not in the team, correct? So there are 3 choices for one person. Similarly, for the second person, there are 3 choices. For the third person as well, for the fourth and fifth person. Okay, so this is 3, 3, 3, 3, 3. So by multiplication rule, it will be 3 raised to the power 5. So here we have 3 raised to the power 5, which is 243. So the total number of possible ways in which they can join the team is 243 ways. Okay. Now, question third. how many 5-digit numbers can be formed with repetition from the numbers 0 to 9? So there are how many digits? 1, 2, 3, 4 and 5. Okay? And the numbers are being repeated here. And the numbers are chosen from 0 to 9, right? So there are in total how many numbers? 10 numbers are there. From these 10 numbers, we have to make a 5-digit number. So for the first case, for the first digit, we will be choosing out of 9 numbers, right? We are not considering the 0 because if the numbers starting with 0 can like it will be like 4-digit number, right? So we will be excluding the 0 digits. So in total we have 9 numbers. So out of these 9 numbers we have to choose 1 digit, right? So there are 9 ways. For the second, here we have repetition. So in total we have 10 digits, right? So there are 10 ways to select. Similarly here, here and here. So it will be equal to 9 into 10 raised to the power 4. That is option 1. So let us see the solution here. The number of ways to select the first digit is 9, as 0 can't be the first digit. The number of ways to select each of the remaining 4 digits will be 10, as repetition is allowed. Therefore, the total number of ways to form a 5-digit number will be 9 into 10 raised to the power 4. So option 1 is correct. Okay. Now, question 4. Find the value of n such that np3 upon n plus 1 p2 is equals to 1 by 2, where the condition is n is the natural number. And we know so here we know the formula of NPR, right? Which is factorial n divided by n minus r factorial. Correct? So let's look into the solution. Okay, let's solve it step by step. It is given np3 divided by n plus 1 p2, which will be equal to 1 by 2. Okay, let's expand this. So it will be equal to n factorial divided by n minus 3 factorial. Correct? Now let's expand this one, which will be equal to n plus 1 factorial divided by n minus 1 factorial, which is equal to 1 by 2. Now here we are expanding the numerator, that is n factorial and n plus 1 factorial, right? So n factorial will be n into n minus 1 into n minus 2 into n minus 3 factorial. Okay. Similarly, n plus 1 into n minus 1 factorial. Okay. So I have stopped till n minus 3 and here I have stopped with n minus 1. Why? Because we have in the denominator we can see n minus 3 factorial is there and n minus 1 factorial is there. So these values can get cancelled. Okay. Okay, so these values are cancelled. So the remaining part is n into n minus 1 into n minus 2 divided by n plus 1 into n, which is equals to 1 by 2. Okay, this n cancelled. Now this n cancelled, right? So here we can see this we have reached till here. Now we're going to solve this and make this expression, which will be n plus 1, sorry, n minus 1, n minus 2 divided by n plus 1 equals to 1 by 2. Let's cross multiply. It will be 2 n minus 1, n minus 2 equals to n plus 1. Let's open the bracket. N square minus 2n minus n plus 2 equals to n plus 1. 2n square minus 3n plus 2 is equals to n plus 1. Let's multiply. 2n square minus 6n plus 4 equals to n plus 1. Let's put this value here. Okay, we will get 2n square minus 7 plus 3. Okay, so we've got this expression. Now we're going to solve this. Okay, now if we middle split it, we get middle term splitting. We get 2n square minus 6n minus 1n plus 3 is equals to 0. Take 2n common, we get n minus 3. Here we have 1 as a common, we get n minus 3 equals to 0. So n minus 3 and 2n minus 1 equals to 0. So now the values of n will be n, 3 and 1 by 2. There are two values here, right? And here the condition is n is a natural number, so we will only consider n is equals to 3. Okay, so our answer is n is equals to 3. Okay. Now question 5. Five classmates could not agree on who would stand in the group photo along with the teacher for the yearbook. How many possible groups can be made such that there is at least one student with the teacher in the photo? Okay. So in total, how many classmates are there? There are five classmates and there is one teacher. Okay. So the question is, how many possible groups can be made such that there is at least one student with the teacher? Okay, so the condition is there should be a student with the teacher. Now the solution is, for each of the five students there are two choices, right? Either they are included in the group photo or they are not, right? Like if these are the five students, so for the one student there are two choices, right? They are included in the group photo or they are not in the group photo. Similarly for the second student also, third, fourth and fifth. So for the whole five students there are two choices each. Okay, so the total number of possible combination of students along with the teacher, right? So here if they are in the group photo, that means they are with the teacher. Okay, if he is like the first person is in the group photo, then he is with the teacher. The teacher is already in that scenario. Okay, otherwise if he is not, then also the teacher is there, right? For the second person also, if he is in the group photo, that means he is with the teacher, so the teacher is along with them. So the total number of possible combination will be 2 raised to the power 5 equals to 32. Okay, now also one of these possible group consists of only the teacher, right? Like nobody is on the group photo, right? No student is being there with the teacher. Okay, so which we need to exclude since the problem requires at least one student and we can't consider that, right? The question asked is that there should be at least one student present with the teacher, right? So we're gonna exclude that condition in which there is no student with the teacher. So therefore we subtract this case, we get 32 minus 1, which is 31 possible groups where the teacher is accompanied by at least one student. So our answer is 31. These are the 31 possible groups where the teacher is accompanied by at least one student. Okay. Now question 6. Compute the following expression: factorial 10 into factorial 5 upon n factorial into 1 factorial into 0 factorial. Okay, so we know the expression of n factorial, right? It can be written as n into n minus 1 factorial, or it can be written as n into n minus 1 into n minus 2 factorial, right? So we have to look into the numerator and denominator and we have to expand in such a way that they can cancel, right? So here, so 10 factorial will be 10 into 9 factorial. 5 factorial can be expanded as 5 into 4 into 3 into 2 into 1, which is 120. And 0 factorial and 1 factorial is equals to 1 only. So if we put the values 10 factorial, 10 into 9, 5 factorial, we have expanded it and the value is 120 divided by 9 factorial. Okay, we are not expanding this, and 1 factorial is 1 only and 0 factorial is also 1, right? So here this will get cancelled, so the remaining will be 120 into 10, which is 1200. Okay, so this is our answer. Okay, now let's solve some questions related to EMQ. Now the question is, Rohit wants to set a 3-digit password for his office desktop which can be created by following either pattern A or pattern B. Okay, so there are two patterns, pattern A and pattern B. In pattern A, the first two digits are alphabetical and the remaining one digit is numeric. So for pattern A, the pattern is the first two digit are alphabets. Okay, these are two alphabets and the one digit is numeric. Okay, only lowercase alphabets can be used in the password. Okay, the condition is lowercase. Okay, now in pattern B, so here we have with our second pattern, the first two digits are numeric. Okay, here the first two digits are numeric and the remaining one digit is alphabet. Okay, so the last digit is alphabetical. So the note is only lowercase alphabets can be used. So the question is, select the steps applicable for selection of digits for password of type pattern A. So in pattern A, we have the first two digit as lowercase alphabets and the last digit as numeric. So what are the steps? The first is selection of digits will occur simultaneously, or the selection of digits will not occur simultaneously. Here we are considering the digits are being selected simultaneously, right? That is, when Rohit is creating his password, he is choosing all the digits, whether they are letters or numbers, for the password at the same time rather than sequentially. That is, the choices for each part of the password are considered in combination rather than one after the other. So option 1 is correct. Now, here the selection of the digit is simultaneously, right? So that means it is without replacement. Okay, it is not, we are not replacing it, we are not repeating it, and here the order matters. So let's look into the solution. The selection of alphanumeric digit for password of pattern A will be simultaneous and without replacement, as it is mentioned that repetition of digit is not allowed. Also, order of digit do matter because password AB2 and BA2 are different, right? So here the order matters. So option 1, 4 and 5 are correct. Okay. Now, the second part, in how many ways can he select password of type pattern A? So in how many ways? So for type A, it was the first two digit as alphabets and it should be lowercase, right? And the third digit should be numeric, right? So in pattern A, the first two digits are lowercase alphabets and the remaining one digit is numeric. So number of ways to select the first digit is 26 and number of ways to select the second digit will be 25 because repetition is not allowed. So one alphabet is only is already selected in the first digit, right? So there are remaining 25 digits. Sorry, 25 alphabets. So there are 25 ways to select the second digit. Number of ways to select the third digit will be 10. We are considering numbers from 0 to 9, so there are 10 digits, so there are 10 ways to select the third digit. So the total number of ways to form a 3-digit password, applying the multiplication rule, we get 26 into 25 into 10, which is 6500. So this is our answer. Okay, now the second part, select the steps applicable for selection of digits for password of type pattern B. So in pattern B, it was the first two digits should be numeric and the third digit should be alphabet and it should be lowercase, right? So this was the pattern. So here also we are considering the selection of digit will occur simultaneously only, like I had explained in the previous question also for the type pattern B. It is without replacement and here also the order matters. So if we look into this solution, we get the selection of alphanumeric digit for password of type pattern A will be simultaneous without replacement. Also the order of digit do matter because 23D and 32D are not same. So option 1, 4 and 5 are the correct option. Okay. Now, the second part of this question is, in how many ways can he select password of type pattern B? Okay, so then pattern B, the first two digits are numeric, the remaining one digit is alphabetical, correct? So numeric, that is we have to consider the numbers 0 to 9. So the number of ways to select the first digit will be 10 only. It will not be 9 because password, like it's a password, it's not a number, right? So it is like we can have password starting with 0, 1, A. We can have password like this, right? It's a password. Okay. So here for the first digit we have 10 ways to choose the from 10 ways to choose the first digit, right? 0 to 9. Then number of ways to select the second digit will be 9 because repetition is not allowed and one digit has already been selected here. Okay. Then number of ways to select the third digit will be 26, right? Now, therefore, the total number of ways to form a 3-digit password of pattern B will be 10 into 9 into 26, which will be equal to 2340. Okay. Now, in how many ways can he select the password for his office desktop? Okay, so he can either select password of pattern A or pattern B. There are two options, right? And the total number of ways to form 3-digit password of pattern A was 6500, that we have calculated in the earlier question. And similarly, in the earlier question only, like in the previous question, we came to know the total number of ways to form a 3-digit password for pattern B was 2340. So if we add both these numbers, we will get the total number of ways to form a 3-digit password for the office desktop, which is 8840. Okay. Now, question 8. For a card game, 5 seniors and 4 juniors are seated on a 9 chair at a round table. Okay, here we have a round table. How many seniors are there? 5 seniors are there. Okay, and we have 4 juniors. Now, from the given list of options, select the steps applicable for sitting around a round table. So these are the options. The options are: selection of members will occur simultaneously, selection of members will not occur simultaneously, with replacement, without replacement, order matters, order does not matter, permutation is used, and combination is used. So we have to select the options here. So let's look into the solution here. The sitting arrangement of all the members will be simultaneous and without replacement. Okay, that is, one member can take only one position only, right? So option 1 and option 4 are correct. Then let the 5 seniors be S1, S2, S3, S4, S5, and 4 juniors will be J1, J2, J3, and J4. Okay. Then the seating arrangement, this is different from this. Correct. Here we have the seniors first, then the juniors. Here we have the juniors first, then we have the seniors. So here the seating arrangement are different. So order of the seating arrangement does matter here, right? So we are and we are also arranging the members in circular arrangement. The permutation is used here. So option 1, 4, 5, and 7, which are, that is, selection of members will occur simultaneously, without replacement, order matters, and permutation is used. These are the 4 options that is correct. Okay. Now, for a card game, 5 seniors and 4 juniors are seated on 9 chairs at a round table. Same question. Find the total number of possible ways such that the 4 juniors are always sitting next to each other. Okay, all the 4 juniors, that is J1, J2, J3, and J4, they are all sitting together. So the solution is, number of seniors are 5. Number of juniors are 4. It is given that all the 4 juniors are placed next to each other. So we will consider the 4 junior as only 1. So how many people are there? 6% in all, right? There are 5 seniors and there is 1 junior, correct? In one there are 4 junior included, right? In this situation, we are considering all the 4 juniors are sitting next to each other. So we are just combining it into 1. So there are 5 plus 1, which is 6% in total. So who can be seated at a round table in 5 factorial ways? Correct? Because for a circular, the permutation is n minus 1 factorial. So here n is 6. So n minus 1 will be 6 minus 1 factorial, which is 5 factorial. Okay. Further, since the 4 juniors can interchange their positions, right? Here, like if this is J1, J2, J3, and J4. These are the, like, they are sitting like this. Also they can sit it like J3 here, J4 here, J2 here, or they can sit like J3 here, J4 here, J1 here, J2. So they can sit, they can arrange themselves, they can interchange their positions, right? So there are 4 ways by which they can do that, right? So there are 4 factorial ways. So therefore the total number of ways to place the 4 juniors together will be 5 factorial into 4 factorial by multiplication rule of counting, which will be equal to 2880. Okay. Thank you.